Hey there, let's talk about how you go about determining Lewis dot structures for various compounds. This will be only, of course, for compounds that are molecular compounds or covalently bonded compounds. We will never do this for ionic compounds. We will do this for covalently bonded compounds that carry a charge. These polyatomic ions are covalently bonded to each other. They just carry a charge, be it negative or positive, but nonetheless, should just be clear that this is something that is only for covalently bound molecules. Now, that being said, the first step is to total number of electrons. So we see, when I say electrons, I'm referring to valence electrons. Carbon has 4 valence electrons, and hydrogen has 1, but there's 4 of them in this case. So that is a total of 8 valence electrons that you need to show in your structure. Now, the way you go about actually creating the structure is look at the formula. Typically, the first atom in the formula is your central atom. The rest are spread around it. So you will take your central atom, put it somewhere convenient, and then bond your other atoms to it. Just kind of spread them around evenly. So I will spread the hydrogens around, just evenly around the carbon. As a side note, I could have also done the same thing using 2 dots for each chemical bond instead of a dash. This is because we understand that when we show a chemical bond like this, it is equivalent to showing 2 dots, which I should emphasize, these are electrons. A chemical bond is 2 shared electrons. These are shared electrons. So this is 2 ways of showing the same thing. Chemical bond, the reason why you don't use this for ionic compounds, by the way, is this shows that 2 electrons are being shared here, 2 electrons here, 2 electrons here, 2 electrons here. Ionic compounds don't share electrons. They give electrons or receive electrons, but they don't share. So sharing electrons is what we've got here. Now we see that you have a need to have 8 valence electrons in your structure. How many are here so far? Now that I just bonded them together, that's 2 electrons, 4 electrons, 6 electrons, 8. There's already 8 here. I don't need any more, so we're going to call this finished. This is done. Here, we will take the same approach. Nitrogen has 5 valence electrons. Hydrogen has 1, and there's 3 of them. So 5 plus 3 equals 8 valence electrons. So we take that and run with that. 8 valence electrons got to be placed, so we're going to take this, and nitrogen must be the central atom. Hydrogen spread around evenly. It doesn't matter how I put them. I could put hydrogen on top, or I could put it on the side. I could put the third one on top, bottom, who cares where. As long as you show it's attached to the central atom, it doesn't matter how you show it. So 1 nitrogen, 3 hydrogens, there it all is. I have 2, 4, 6 so far. I need a total of 8. Well, what do I do? Where do I put this? I need 2 more valence electrons. Do I put them here, 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 or here? They got to go in one of the atoms. Well, this is where the octet and duet rules come in. Hydrogen can never have more than 2 electrons. Here it has 2. Here hydrogen has 2, and here hydrogen has 2. So these hydrogens cannot take any more, so I cannot put like 2 valence electrons here or 2 valence electrons here because there's already 2. That would be giving, if I put 2 here, that would be giving hydrogen a total of 4, and hydrogen can't have 4, it can only have 2. Nitrogen, on the other hand, like all the elements you're going to deal with that are not hydrogen, must have 8 valence electrons. 2, 4, 6, it doesn't have enough, and I need 2 more anyway, so I'll put them here. 8. 2, 4, 6, 8 valence electrons. Now hydrogen has 2 each, and then the thing that isn't hydrogen has 8. That's the way it should be. Back here as well. You'll notice hydrogen only has 2. Carbon has 2, 4, 6, 8 valence electrons, just as it should. So I didn't mention it earlier, but it applies here just as here. You must make sure that all non-hydrogen atoms that you're going to deal with for this class are given 8 valence electrons. Now, just to be clear, this is one of 2 things you're going to do to check to make sure you did it right. Because you might be looking at this and like, imagine someone just showed you this and asked, is this right? Well, my response would be, and yours should also be, does it A, have the right number of electrons, need 8, 2, 4, 6, 8? needs 8, 2, 4, 6, 8. Okay, that's one thing. 2, have you satisfied the octet and duet rules? That means hydrogen has 2, hydrogen has 2, hydrogen has 2, hydrogen has 2. This thing, which is not hydrogen, has 8. Good, that's the way it should be. Hydrogen has 2, 2, and 2, 2 for each hydrogen, and the thing that isn't hydrogen has 2, 4, 6, and 8. That's the second thing. So check the octet and duet rules, and check the total number of electrons, make sure they're right. If both of those conditions are satisfied, you are correct. So you, the viewer, are invited to try these next 4. Well, actually, hold on a sec. Before I invite you, the viewer, to try these out, let me jump ahead to one that will provide a new challenge. Now, I suppose, all right, I'll just do these in order. So you, the viewer, I encourage, pause the video, try out the water. Same method is used here, and then I'll put the answer here and you can see if it matches. So pause now. And okay, I'll assume you worked it out. Here's what you should have done. 1 electron, and there's 2 of them. I should say 1 valence electron. This has 6 valence electrons, excuse me. So that's a total of 8 valence electrons. So, right, need 8 valence electrons. So I take oxygen, central atom. And this is an exception. Not always will the first thing be the central atom, but in this particular, most of the time it is. Now in this particular case, it's obvious hydrogen is not the central atom, because look, hydrogen can only take 2 electrons. If you had like something else, something silly, something like, oh, I don't know, maybe like if you did try to make the hydrogen a central atom, like that, this would not be possible simply because the fact hydrogen can't have more than 1 bond. Here you're showing hydrogen with 2 bonds and 4 electrons total, 4 valence electrons. You can't do that. So that's why this is correct. So step 1, find the valence electrons. Step 2, separate or lay out your atoms. Step 3, add your electrons. I need 8. 2, 4, can't add any more to the hydrogen, so 6, 8. Now the final check. A, 2, 4, 6, 8. It has the correct number of valence electrons shown. B, duet rule satisfied. Octet rule satisfied, 2, 4, 6, and 8. And duet rule satisfied, 2. Therefore, I know I have put this together correctly. Hopefully you got the same. This is a little more of a sort of a challenge, because here's the thing. This one is going to, if you just follow this, you're going to find an issue. In fact, here, rather than try to describe it, let me show you. So there's 2 carbons with 4 electrons each. Here we have 2 hydrogens with 2 hydrogens with 1 electron each. So 8 plus 2 equals 10 electrons, or rather 10 valence electrons. So first of all, wait, how do I do with 2 central atoms? Well, put them both in the center. What do I do with these? Spread them evenly. So 2 hydrogens, fine, I'll put 1 here and 1 here. Now I need to place 10 electrons. 2, 4, 6. I don't know, 8, 10. All right, fair enough. What do I do? Here's why this is a problem. I can't add more than 10 electrons. 2, 4, 6, 8, 10. I've got 10 electrons. And the octet rule, so okay, that's one thing, right? But if I check on the octet rule, this has 2 like it should, but this one has 2, 4, 6. This one has 2, 4, and 6. These fail to follow the octet rule. What do we do? The answer is you have them share these electrons in order to make it work. So I'm going to take these pair of electrons and bring them down here and have it so that the carbons share these 2 electrons. These 2 electrons become an additional bond. 2, 4, 6. Well, this carbon still isn't satisfied, but check what happened here. 2, 4, 6, 8. This carbon's satisfied. Ooh, that worked. So let's do the same thing to this one, because making a double bond got me close, but not quite yet. So let's take this thing and bring it down and make it into another bond as well, so that they can share. So instead of this carbon having these electrons to itself, these 2 can now share these electrons. Oops, there we go. So I took those electrons, bring them down here. They form another bond. So yes, the lone pairs that were here have now come to be shared instead of held all themselves. Look, 2, 4, 6, 8. This carbon has got an octet. This carbon has 2, 4, 6, and 8. It also has an octet. This is how we deal with those situations when the electrons given are not enough to go around. You try a double bond, and if the double bond doesn't work, you try a triple bond. So we can apply that to another one of these. Let me actually point out another one that has the same sort of issue as here. This one, nitrate atom. I invite you, the viewer, to pause this video and try the nitrate. Pause now. Okay, so let's see what you would do. Nitrogen is 5 valence electrons. Oxygen is 6, and there's 3 of them. And the fact that it has a negative charge means you have to add 1 more valence electron. All right, well, let's see, what is that total? 5. This is 18. 5 and 18 makes 23. That plus 1 makes 24. All right, so next I'll take the central atom and spread these around. Oxygen, oxygen, oxygen. And add all 24 electrons. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24. There's a total of 24 electrons placed. So the number of electrons is correct. Does it satisfy the octet rule? 2, 4, 6, 8. This oxygen's good. 2, 4, 6, 8. This oxygen is good. 2, 4, 6, and 8. This oxygen is good. 2, 4, 6. Uh-oh, this nitrogen has a problem. Well, just as before, we took one of the lone pairs, made it into an extra bond. So let's grab a lone pair. Who cares which one? Maybe this one. And we'll make it into an extra bond. So, doing as much. It's still 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24 electrons. And now, this has a full octet. This has a full octet, 2, 4, 6, and 8. This has a full octet, 2, 4, 6, and 8. And the nitrogen has 2, 4, 6, and 8, just as it should. Hey, this is nitrogen, or nitrate atom. This works. Last step, it is a charged molecule. Let's put brackets and add a charge. And for those of you who might have talked about resonance so far, this double bond could have been here or could have been here. So yes, this has resonance. Now, unlike, by the way, these ones, there's nowhere else to put this multiple bond, and these don't even have multiple bonds, thus they have no resonance. I invite you, the viewer, to try this one out. This works in the same way. You'd have to, it's got a charge. You'll have to account for that in the electron numbers, and you have to add brackets and a charge. I'd like to invite you, the viewer, try this one out, and then check in a little bit to see if I solved it the same way as you did. Pause the video now. Okay, let's see what you did. 4 electrons, 4 valence electrons times 2, plus 6 valence electrons times 4, plus, on account of this, add 2 more electrons. So that's 8 plus 24 plus 2, so that's 32, that's 34 electrons. "34 valence electrons." Okay, let's take these two, put them in the middle. Let's take the oxygen, spread them around. Who cares how? Just because it's kind of crowded up here, I'll put the oxygens like this. Not that it matters. Just evenly spread them. All right, I got 34 electrons to place. Let's see what I got so far. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26, oops, running a little tight there, 28, 30, 32, 34. Uh-oh. I have placed all 34, and I'm not done it because 2, 4, 6, this carbon doesn't have 8 yet. 2, 4, 6, this carbon doesn't have 8 yet. These oxygens all have 8. They're fine. But the carbons have a problem. So you know what we're going to do? Let's make some double bonds. Here, I'll just grab this one because it happens to be handy. I'll make that into a double bond right there. Oops. Oh no, work with me here. Okay. All right, got the oxygen and move these lone pairs to make a double bond. Okay, what did that do? 2, 4, 6, 8. This oxygen's still good. 2, 4, 6, 8. This carbon is now good. Now this carbon has a problem. So let's take, oh, I don't care, either one. One of these needs to supply its electrons to make a double bond. Let's have it be, I'd randomly choose you. Let's have it move these electrons. So there, let's wipe that out. This lone pair has now become an additional bond. 2, 4, 6, 8, 2, 4, 6, 8, 2, 4, 6, 8, 2, 4, 6, 8. All oxygens are good. And this carbon has 2, 4, 6, 8. This carbon's good. 2, 4, 6, and 8. This carbon is also good. This would be an acceptable structure for this, which is named oxalate ion. And of course, let's not forget our brackets and charge. I invite the viewer to try these out. Pause now, and in a moment I will put up the answers. Ready? Here they are. Ten electrons wasn't enough, needed a multiple bond. 8 electrons was sufficient. You don't need a bond every time. Don't get carried away to using multiple bonds for everything. If you've got enough electrons to go around, you've got enough electrons to go around. Not forgetting, of course, to add 1 extra to the total on account of that charge. Last one to show you as an example is on the back side of what you would probably receive this as a double-sided handout. Here I've got it printed on a single page. Actually, I guess got a couple more examples I can do. But what if you have one like this with a plus charge? Well, 5 valence electrons, 6 valence electrons. Well, you got to add an electron to make a negative charge because electrons are negative. In order to make a positive charge, instead of adding, you subtract an electron. So on account of this, -1 from the total number of valence electrons. That's what this is for. So 5 plus 6 is 11, -1 equals 10 valence electrons. Well, cool that. So I just take N and O and make sure I got 10 electrons. 2, 4, 6, 8, who cares where? 10. I could have put that here or here, it doesn't matter. 2, 4, 6, 8, 10. Oxygen is good, nitrogen is definitely not, it's only got 4. So let's take this pair and move it down to become a shared bond. 2, 4, 6, not enough. 2, 4, 6, 8, this oxygen is still good. So let's take this pair and move it into here so it can become a shared pair of electrons as well. So this now moves here. 2, 4, 6, 8. This nitrogen is good. 2, 4, 6, 8. This oxygen is good. We've wound up with a triple bond. All right, it works. And because it's positive charge, we include brackets and a charge. So these work just the same as all the other ones you've come across. I suppose the last example I can give that is in any way new or novel might be something having to do with this. Okay. Why is it H3COH and not H4CO? Why is this listed separately? Well, it's because this is an organic chemical known as an alcohol, and it is written this way to give you a hint on how it goes together. This OH means that the molecule involves O and H, like so. So the rest of it is just gathered over here, but I'm being a bad example here. I do need to show you how to properly do this. So we start with 1 electron times 3. This has 4 valence electrons. This has 6 valence electrons. And this has 1 valence electron. 3, 7, 13, 14 electrons. So, all right, we take H3C, so we'll just take C and put 3 H's on it, just like the formula says. Basically, what's happening is this is your one central atom and this is another central atom. So you see how this shows this? H3C, H3C, OH, OH. Now wait, do I even have 14 electrons? Let's check. 2, 4, 6, 8, 10, 12, 14. Hey, look, that worked. And does it satisfy the octet rule? Well, first of all, hydrogen each has 2. Good. Octet rule? Yep, carbon's good. Octet rule? Yep, oxygen's good. And this hydrogen has 2. So this is a perfectly well put together structure. So I suppose the last thing that could be mentioned, okay, I guess there's one more. Here, what the heck? How do you deal with this? Well, first of all, silicon is, what is that, 4 valence electrons. Chlorine is 7. 2 times 7, there's 2 of them. And bromine is also 7 valence electrons. So that's 4 plus 14 plus 14, which is 4 plus 28, which is 32 electrons. What it's telling you is that silicon is going to be your central atom, and chlorine and bromine are both attached to it. So just don't get used to it always being 4 of the same thing when you have 4 things attached to the central atom. It can be multiple different things. Now you just count out your valence electrons, 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26, 28, 30, 32. Oh, done. 32, have 32. This has 8, this has 8, this has 8, this has 8, and this has 8. There's no charge, so I don't need brackets and a charge. Done. So just be aware that if there's more than one thing attached to it, this is really the only way we can possibly represent it. The rest of these all work the same way as what else you've seen, so go ahead and do your best with them. And I think that's about all that can be covered here. All right, there you go. Happy studies.